Welcome to this maths video on 2D shape problems. We're going to start by looking at reverse area and perimeter. If you're given all the measurements except one, and either the area or the perimeter, you can work out the remaining measurement. For example, here I have a rectangle with a length of 6 centimeters, an area of 8, and I want to work out the width. Well, I know that area is length times width, and 6 times 3 would give me 18. So my width is 3 centimeters. Let's have a look at an example. What is the length of the rectangle below? We start by writing the formula. Area equals length times width. I can then write in the numbers that I know. I can substitute in the numbers, and I have 54 equals L times 6. Well, I don't want L times 6, I want just L. So to get rid of the 6, I divide by 6. That will give me 1, leaving just L on this side. However, whatever I do to this side of the equation, to this side of the equation, I need to do exactly the same. So I'm going to divide 6 on both sides of the equation. Well, 54 divided by 6 is 9. So L equals 9. These are in centimeters, so my answer is also in centimeters, so it's 9 centimeters. To work out the perimeter of this shape here, we'd add up all the sides. So I've got these sides, and the perimeter, I'm told, is 19 centimeters. And I want to work out this side here. Okay, so perimeter would be 3 plus 5 plus 7 plus this one here. My perimeter is 19, and 3 plus 5 plus 7 is 15. 3 plus 7 is 10, plus 5 is 15, plus L. I can take 15 from both sides, and my length, I can see, is 4 centimeters. Area and perimeter. Area can be used to find the perimeter, and perimeter can be used to find the area. What I need to do is do exactly what I've just done in the last section, find the missing side, and then use that side to calculate the area or the perimeter in the normal way. Reflective symmetry. A line of reflection can be thought of in 3 ways. A mirror line. If I put a mirror here, what I see in the mirror is exactly this here. A fold line. If I fold along the fold line, everything here is exactly on top of everything here. A line where every point on one side of the line has a corresponding point the same distance from the line on the other side. So this point here is at the same distance from the line as this point here. You're moving away from the line in opposite directions. This point here is the same distance from this line as this point here is. This line is closer to the center line than this point, so this point here is closer to this line of symmetry than this point here. This goes up and towards the line, so this bit goes up and towards the line. For a regular polygon, the number of sides equals the number of lines of reflection. So a regular 3-sided shape called a triangle has 3 lines of reflection. A square, 4 lines of reflection. A regular pentagon, 5 lines of reflection. A regular hexagon, 6 lines of reflection. Rotational symmetry. A shape has rotational symmetry when it looks the same after rotation of less than 1 full turn. Looking at a 6-pointed star, 1 point has been shaded to show you the starting point. And we can see as we go around, I've gone around here just 1/6 of the way around, and the star shape is exactly the same as it was here. And then again, it's exactly the same, exactly the same. So the star has a rotational order of 6 because it looks exactly the same as the starting point 6 times in a full rotation. For a regular polygon, the number of sides is the same as the order of symmetry. So here I have a regular hexagon, and as it is rotated around, it's the same 6 times. Something that has reflectional symmetry does not necessarily have rotational symmetry. And a shape with an order of symmetry of 1, that is, it's only the same in one position, we say has no rotational symmetry. This is because there's only one position that the shape looks a particular way.